the hour. We've got, I suppose, we're very close to the registered numbers of people joining us. And yeah, I see everyone can see the screen. Thanks, Georgie. So look, first of all, thanks for joining us today for this webinar on accessing efficient energy modeling in Revit using FenestraPro version 7. I hope today we'll give you some good information and some good takeaways to consider as we go through the presentation. So today the presentation is being given by myself and my fellow founder of FenestraPro, Simon Whelan. Simon and I are both architects with masters in various different disciplines, including facade engineering for myself and advanced energy environmental systems from Simon. We both had extensive experience as directors in architectural firms, and between that academic research and our experience, we led to the concept of FenestraPro, and that's what we're here to talk to today. So I'm going to take the first half of the webinar, and then Simon will step in and take the second half. So hopefully we'll get through it at a reasonable pace today. The agenda for today's call will be a general introduction. We'll talk a little bit about the impact of the facade, both in terms on operational energy, but specifically around kind of the performance indicators related to the performance of the facade, thermal performance, heat gain, and natural daylight. We'll look at briefly what metrics that matter, and we briefly touched on that there a second ago. We'll do a brief introduction to FenestraPro version 7. So this is our latest iteration of FenestraPro with a fairly new and sophisticated workflow that makes the energy modeling a lot more accessible. And we'll look on and spend a bit of time talking about that today. That's when Simon will take over. Briefly touch on what's coming soon, and we'll leave some time at the end of the presentation for a Q&A. I will say at this point, if you have any questions that you want to get out there, please feel free to use the chat. If it's a burning question, or Meg will interrupt me and ask the question. If not, we can wait towards the back end of the presentation where we can kind of deal with those with the questions as part of the Q&A. Okay, so look, to very briefly introduce FenestraPro. So we provide BIM and web-based software that's very much focused on facade design and optimization, based on glazing specification and configuration and glazing configuration to optimize the performance of your facade and specifically the building, specifically for energy efficiency, but also for occupant comfort. Our tool sets are approved under the AIA 2030 palette, which is a resource for the design of zero carbon, adaptable and resilient buildings. And what I would say, just to kind of get a sense of the amount of energy that the facade is responsible for. It's a very useful diagram that we look at here. The facade represents or controls over half of the energy used in buildings, and again, it does that, obviously by controlling the heat loss, but also by enabling, I suppose, a passive solar heat gain, and how you control that heat gain to make sure that the building isn't overheating, so you're reducing your cooling loads, but also trying to maximize that amount of natural heat to reduce your heating loads. In addition to that, we also look at how we can maximize artificial or natural light to reduce the requirement for artificial light. So total, as I mentioned there, total energy use that's controlled by the facade is over half. 57% of total energy use is controlled by the facade. More and more we're seeing, I suppose, requirements for calculating embodied energy. And I think it's important to point out that over a quarter of the embodied carbon of a building is made up from the components of the facade. So 26%, as you can see there. So again, that's something we're looking at introducing to the software, and Simon will touch on that later on in the presentation. So FenestraPro is used by architects, engineers, facade consultants to, first of all, manage your glazing in terms of the amount of glazing that you have on the building, to enhance the thermal performance of the building. So we can look at the overall thermal performance of a building and how the various components fit into that overall performance. So if you think about it this way, the overall performance of the building, requirements are typically controlled by code. When we have those elements in terms of how, the wall, the roof, the floor, and the glass being the weaker part of the facade performance in terms of thermal heat loss. If you can, I suppose, control that in such a way that you can maximize the amount of glazing that you have in the building to get the other benefits that we're going to talk about momentarily, and keep that within the overall thermal performance of the envelope, you can optimize and maximize the amount of glass that you can have in the building. So again, managing glazing percentage and U values to enhance the thermal performance. Optimize solar gains to reduce your requirement for cooling and heating, as well as maximizing the daylighting to reduce the requirement of artificial lighting. And very often we see these things that they work against each other. So, where you have, I suppose, excessive or let's say a lot of glazing, that's obviously a weaker thermal performance. So therefore your thermal performance of your glazing and your walls, your roof and your floor has to compensate to try and improve that overall thermal performance. So where you've got a lot of glazing, you also get a lot of solar gain. And that's a good thing in some ways, but obviously you've got to manage and control that so you're not overheating the building and therefore relying on additional cooling to control the environment within that. And again, where you get a lot of glass, you get, I suppose, we're looking at how we can maximize the amount of daylight coming into the space and ultimately try and prevent glare. Big consideration on that is two things as we look at it: is the geometry in terms of how much glass, where the glass should be, distribution of glazing, in terms of the configuration of your facade, of that fenestration arrangement, but also very importantly the glazing specification and the specification as well of the other components. But the glazing has more to do with obviously you've got solar heat gain coefficients in terms of the amount of heat gain coming through the space and trying to maximize that daylight. So these are things, as I said, those parameters certainly work against each other. And what we're trying to do is find that optimal solution to optimize the performance of your facade using Fenestra Pro. Fenestra Pro version 7, which we're going to talk a little bit about today, is an Autodesk Revit application. So it's a plug-in to Revit that demonstrates the impact of your design decisions and specification decisions from really early in the design process to optimize energy efficiency within the BIM workflow. So as a plugin, that enables us to read from Revit and write back to those design decisions back to the Revit model, and also embedding that data into the Revit model to ensure that we get that optimal performance from the facade. As I mentioned a moment ago, we've looked at the facade geometry, which we tend to refer to, I guess, as the that glazing arrangement, that fenestration arrangement, but also the component specification, and particularly around those performance criteria. So as I mentioned with glass, it's U value, so heat gain coefficient, visible light transmittance. When it comes to the opaque elements like your wall, your roof, and your floor, it's predominantly your U value. Again, U values in thermal performance being controlled by code, and obviously ensuring that you're meeting code while designing your buildings. The other aspect of that is the component specification, and again, if we look at it this way, where we generate lots of information within the application. So again, being able to extract that information from Revit and present it in a presentation format in terms of some of that data, and we can go quite granular, where we can look at the overall building itself, the entire building, and look at average U values or average heat gain across the building, or we can zoom in on a particular surface which is part of a facade. And if you think about it this way, we generate lots of information on the basis that we've got the heat gain on an hourly or daily basis across the year, as well as annual averages or monthly averages, that we can provide that level of information that you can report on to ensure that you're managing those peaks and troughs within the across the year, depending on the orientation, inclination, the impact of shading from surrounding buildings. Fenestra Pro very much supports you to design more energy efficient buildings, and we talk about Fenestra Pro as a design tool, and very much we see it as an optimization tool. And again, understanding, I suppose, what the outputs are based on your design decisions, and how that feeds into the overall performance of the building, and understanding those balances between your thermal, your solar, and your daylighting, and getting that right and optimized, as we say. It enables us to establish and apply the optimal glazing configuration and specification, demonstrates code compliance, and optimize the facade performance, and effectively streamlines the workflow. Because again, by understanding the implications of your design decisions from conceptual all the way through to detailed design, it effectively eliminates the requirement for late stage redesign, whereby typically when mechanical engineers are looking to design the HVAC system or the chiller sizes or cooler sizing, what is that you've got your building to a point where it's optimized. You're not overheating, you're maximizing those heat gains, your thermal performance are in line with code, and you're maximizing the amount of daylight that's coming into the space. Okay, I'm just going to play this video while just introducing version 7 of Fenestra Pro. Okay, so hopefully that gives you a sense of what the application does. And just to kind of get into a little bit more detail and talk about some of the functionality, as I mentioned earlier on, there's a couple of workflows at play here. So we can very much look at that conceptual design stage. Now, as I'm sure you're aware, within conceptual design, within Revit, the walls are effectively paper thin. When you create windows or openings, they're referred to as notional openings. So the Revit model doesn't store the data. The data is stored in the application, whereby it can be managed through the application then as you start to establish the key things that we talked about in terms of the passive solar heat gain, natural daylight, and of course, thermal performance. As I said, at that conceptual stage where you've kind of started to kind of shape or mask that building, you can model also surrounding buildings and look at the impact that has on your distribution of glazing and the shadow effect or shading effect from those surrounding elements. But at that early stage, you can establish things like glass to wall ratio, the optimal distribution of glazing. So in other words, the best place to put the glass to maximize and control your heat gain across each of the individual facades. That early stage glazing specification, so getting an idea of how, I suppose, those criteria can be controlled by material specification or material selection, particularly around the glass, but also around the U value or performance of your opaque elements. Again, understanding the location, orientation, and in fact, the variation based on inclined planes. For example, if your facade is at an angle, there's a different solar load that affects the passive solar heat gain calculations, and all those things are considered. It's a good point to point out the fact that Fenestra Pro uses an independent solar database called Meteornorm, which gives us the solar data and the sun path for every location globally, for every orientation, and also for every inclination, as I just alluded to as well. And as I mentioned earlier on, we can look at the effects of shading from surrounding buildings, or self-shading from the building itself, or indeed from any shading device that you have on the building. Just very briefly looking at the conceptual design tools within Revit and within Fenestra Pro, we see here that we can use, I suppose, we can use the thermal performance to drive that glass to wall ratio, where in this instance we're looking at, a maximum of 40% glazing, and that could be code dependent. So again, you can select various different codes that you would have available to you. You can create your own codes, obviously, or put in your local code, depending on what you're dealing with. You see in that instance then where we've established 40% glass, that 40% is then written to the model in the form of these notional openings. And then you can see where we're getting, good thermal performance values in terms of the U value. We're looking at, where we're getting a slight overheat and where we are sitting with the daylight. We can then select different components based on those performance criteria. For example, glazing. In this instance, we can see, a vitro glass that might address these, these overheats. We can select that, and we can filter based on the, your solar heat gain coefficient, your VLT, and so on. And then you can also select the various different available glass types, apply that to the project, and look at the impact it has when you recalculate those values within the application itself. So you can see here, by using that particular glass, we are reducing our heat gain down a particular level, and we can see that the daylight is coming down as well. Like I said, we can look at that on the whole building basis, or we can look at individual surfaces. You can see here where in Revit, we're selecting, in this case, 3 surfaces. We're increasing the amount of glass to 50%. And we're looking at the real-time feedback in terms of what that does in relation to the performance of the facade or the building itself. Again, we can obviously look at that distribution of glazing, whereby we can equalize the heat gain across all facades, and invariably end up with more glass on your north than you do on your south. And then you can override those considerations for the purposes of, trying to achieve aesthetic. You might decide, well, I want close to 100% glazing on my side facade. So you can set that, lock it in, and distribute the rest of the glass to the rest of the building. The last piece of this video there you can see is where we can customize and create your own charts and graphs to support, I suppose, the demonstration of that optimization to clients or to the rest of the design team. As we move into as we move into the detailed design stage, what we're looking at predominantly is around, how, in this instance, how we read the data within the Revit model. So as I described earlier on, in the conceptual model, the data is not stored in the model, it's stored in FenestraPro. In this instance, the data is very much stored in Revit, and what we're doing is we're reading from Revit and writing to the Revit, that information back into the Revit model. When we look at the version in the detail model, you'll see it's quite different. And this is version 7, and Simon's going to talk a little bit about this shortly, whereby we've now introduced a new workflow that enables us to extract the energy model data from the Revit model and put it into our own environment, and carry out the functionality of FenestraPro separately, but yet still connected with Revit. So as we're iterating through the design, we are looking at how we can then apply that and those design considerations back to the model. And those design considerations is around configuration, the specification of glass. All that information can be written back into the Revit model. So while it looks like a separate environment, it's still very much connected within back into Revit. And that gives us some advantages, particularly in relation to the performance of the application. As you know, Revit is single threaded. You can do one thing at a time, but by exporting the data into our own environment, we're able to do multiple things at the same time and write that information back into the model. I'm going to show you how we can select and apply different glass types, filtered on, based on those performance criteria. And, obviously, I should point out as well at this point that the glazing database that's provided for the project is only providing you with products that are available from the likes of Guardian Glass or Vitro Glass or Viracon in a given region. So again, depending on where you are, we'll select what's available to you in that particular region. Custom imports. So again, while we have our own glazing database, which is made up of predominantly 612 or 616 6 type of glass, you can also customize your own glazing within Vitro's Construct IGU or Guardian Glass performance calculator, and import that glass into the Revit model, where you can apply it then directly into the model itself. We can look at how we define targets and find different glass. We can link, as we saw a moment ago, link to different product pages and access technical assistance through the application. So as I mentioned, you'll see here we've extracted the energy model data into our own environment, and as we select different surfaces or different facades, then we can start looking at how we can apply different glass types. So you'll see here we're searching based on a glazing with a particular, maximum U value, with a maximum solar heat gain coefficient and a minimum visible light transmittance. And again, for each of these products, we can see and link back to their website, or we can contact technical service for additional support. When we select that glazing, we can apply it to one or all of the facades, and you can see here when we apply it to the one facade how that works. And basically, what it's doing, it's embedding that specification back into the actual Revit model. As I said, you can customize your own glass. So again, using Construct IGU or Guardian's performance calculator, you can create the glass and export it back into FenestraPro. In this point here, I'll just pause this very briefly. You can see where we select individual facades or surfaces with one orientation. You can see in this instance, we can select, instead of selecting based on U value or solar heat gain coefficient or visible light transmittance of the properties of the glass itself, you can actually select the performance requirements for the building or for the selected surface, and then, in other words, reverse engineer your selection of glazing to achieve those particular criteria. So you can see here we want a maximum U value for your facade of 2.4. You can see that we've a maximum heat gain and a minimum daylight, and that will refine the selection of glass that you can use and apply back to the Revit model. We can generate configurations, and they could be adding windows or curtain walls. We can define that by configuration or by performance targets, and select different types of glass and look at how we can meet certain performance targets of the building based on various alternating glass types. So an example there will be, if I go with a solar control glass, I might get 6 punch windows on a given space, whereas if I'm using a standard glass to achieve the same results, I might only be able to use 2. So again, kind of combining that aesthetic intent with the performance to deliver a defined geometry for a facade. And you'll see here in this instance where we can select a number of blank facades. We can select a size, or we can select a target solar load or a maximum solar load. So in this instance, we're going to select a maximum solar load of 15 watts per meter squared. We can then refine the search of the glazing based on the criteria we talked about, and then we can look to add whatever number of windows we can achieve, and we can preview them here and then apply them back to the model. And once you've done that, then you refresh the data and you'll get an update as to the various different criteria that we're looking at in relation to the performance of that facade. We can look at heat gain for that facade, or we can look at the natural daylight as a driver. In this instance, we can also do the same for curtain walls. A little bit more sophisticated. You've got to start putting in, obviously, the size of your opening and then your panel to glass ratio, looking at how we configure the grillage within that in terms of where your mullions and transoms are. And again, you can automatically generate that back, and you can see it applying it to the window. Similarly with shading, during the conceptual design stage, you can use the application to establish the optimal depth of a canopy, for example. So to achieve that 25 or 20 watts per meter squared, it'll tell you what that optimal size of the canopy is. So in other words, stops you over designing shading within the process. Or you can look at alternative shading solutions more in the detail model by creating mass objects outside the model, applying that to the model and looking at the impact it has. So again, as I said, you can add those canopies and optimize the depth of the canopies within the conceptual design. We can include shading effects from self-shading, surrounding buildings, or shading devices themselves. And again, we can look at different shading. We can generate a shadow analysis as well from that, looking at the various different things. So you see in this instance where we've got some vertical shading, we can see what the impact that is on the building when we look at that in terms of the shading of the surfaces and how that impacts on the performance. We can look at that as a visual in terms of that shading, I suppose that shading analysis, or that shading animation. You can capture different aspects. You can look at the impact of surrounding buildings and how that will play onto your heat gains and your daylight of given surfaces. So there's quite a lot we can do around that shading in order to optimize and to control the impact and understand the impact of surrounding buildings as well as self shading. Finally, and very briefly, we also have a detailed thermal performance calculator. So we can look at, obviously, when you look at glazing, it's given us a center pane U value. That's going to be combined with your frame, your opaque elements. We can apply those values to the model and look at then a more detailed thermal performance calculation. And within that, as you start adding in and defining the components, and this could be something as sophisticated as a customized panel with nested components, or something as simple as a punched window within the building, where you're adding those variations. So you'll see, for example, in the US, we look at the edge of pane variation. So that's a 2-inch variation, that center pane U value, based on those edge conditions. So it's an edge of pane value under NFRC. In the EU, we look at linear heat loss, or psi values, where the frame meets the glazing, or where the glazing frame meets the wall. So, all those variations are taken into consideration. You apply the various different values for that linear heat loss, or for those edge of panes, the U value for your frame, the U value for the opaque elements, and it gives you that detailed thermal performance calculation with much more detail. So before I hand over to Si, just to give an idea of the kind of firms that are using FenestraPro at the moment. So Skidmore, Owens and Merrill, HKS, the likes of Jacobs, Acom, Page, and again, some of the glass companies that we're working very closely with to provide the data in relation to the glazing performance would be the likes of Guardian Glass, Vitro, and to a lesser extent, Viricon. Some of the projects that we've worked on in terms of those couple of projects on the screen there. Obviously, top left, we had Kuwait Airport, where we've got substantial glazing in a fairly extreme climate, good overhang, and good quality glass that provides a managed process to the actual heat gain itself. At this point, I'm going to hand over to Simon to take over. Simon, can you take control?
Yep, I was thinking of just saying nothing there for a minute, see what you do. Hang on a second, I need to. So I'm not sure if you need to let me screen share here. It says host disabled, participant screen sharing.
1 second. Okay, can you try it now?
Yeah, okay, all good. All right. Yep, can you see it?
Yep.
Okay. Thanks everyone. Thanks, Dave. Sorry, I'm just messing around with Zoom here. I'm trying to start my video, but I can't do that either. So you'll just have to listen to me and not have the joy of watching me too. Thanks, Dave, for going through that. Obviously, there was quite a lot there. What I want to do now is, Dave kind of touched on it, that we have FenestraPro version 7 on release now. A big step change in that is to do with the energy analysis or energy analytical model. I'm not going to go, I'm going to give you a little bit of a demo of FenestraPro in Revit, but just specifically around this energy analytical model aspects of it. I want to just talk about the EAM in Revit, the challenges that we found, how we've overcome those challenges, talk a little bit about that, and then I'm going to jump into Revit and just kind of for 10 minutes, just kind of show that workflow and that on-ramp or, onboarding that FenestraPro provides, because as Dave said, we've slightly new workflows. We're doing things slightly differently to what we did before with regards to that user interface and our own viewer, and how we leverage extract the energy information and data from the Revit model, etc. So I want to give you guys a bit of an understanding around that. I'm going to choose one very small little sort of problem or pain point, to kind of hang that on, and I'm not going to go into the weeds. Dave gave you a really good overview into FenestraPro of all the functionality and all the features. Not going to do that, just going to talk around the energy modeling aspect of it. Talking about Revit for a second, and I would like to think that we have a fair degree of expertise in Revit and the Revit API at this stage. We've been Autodesk Development Network members for quite a number of years. We're also Autodesk AEC industry partners. We're an Autodesk sustainability tech partner. Like, we have a lot of ties with Autodesk. We deal with the Revit API on a daily basis across our team, and we have a really good understanding of what's possible and what's not possible, right? And I think we probably have a few Revit users on the call. Someone put it to me a week or two ago, and I think it's a really good way of putting it. Some of Revit's greatest strengths are also its greatest weaknesses. And what do they mean? Well, Revit is super detailed, and there's loads of different ways of doing things, right? Like you're not bound to one particular workflow or one particular way of doing things. There's loads of different ways of coming at the same design or the same models, and because of the level of detail that's required, that's one of its strengths, there is a lot of detail that needs to go into it. Now, one of the ways that Autodesk deal with that, particularly around energy analysis, is using a thing called the energy analytical model in Revit. So it's native to Revit, it's built within the Revit model, and what it does is it basically looks at the Revit external walls, internal walls, what they call room bounding elements, what's a roof and what's a floor, etc. And it creates this understanding, I guess, this piece of data that understands the analytical spaces, in other words, the rooms, the conditioned rooms or conditioned spaces within that building, and the associated external surfaces, or what they call the analytical surfaces to that model, right? So that's a really great way of breaking that data down. We can understand all of those different rooms and spaces. We can understand perimeter zones. We understand apertures or windows or curtain walls to those spaces, doors, for example. And we can really dig in terms of the energy analysis that can be done. Now, Fenestra Pro, we leverage that energy analysis model, and we always did, because it's ideal for us, because we will then know, Fenestra Pro will then know what is an external surface and what's not, what is an actual window opening and what's not. And that's a really great way of approaching it from our side, and we can play around with different settings, etc. But it also has its drawbacks. Those drawbacks are, again, related to that energy analysis model. So some of those problems that we've seen over in the past few years, and this is through direct engagement with some of those firms that they've spoken about, and users and customers of Fenestra Pro, they've been telling us, and they've been telling us that it's challenging, right? It needs to be a well-built model to generate correctly, right? Like, you need to know what's an external wall and what's an internal wall. You need to assign certain properties if there is glazing or not glazing or whatever. But the crucial thing is, when those things don't occur, it's quite unclear to the user. I don't know as a user what's wrong. I can dig into Revit warnings and issues and stuff like that, but very often I don't know how to, I don't want to, I don't have the time to, and it can be sort of problematic, right? What is the issue? Because we all want to do this energy analysis. I think it's really incumbent, and it's very important on all of us now as designers to really take this, take this energy analysis and building performance as being a key tenet or facet to our building design practices. We all want to do it, but sometimes it can be difficult to do, right? The other side of it is the performance of that energy analysis, or performance of Revit, like more generally, can be quite slow. That's to do with the Revit API, and how we connect or integrate Fenestra Pro to Revit and the energy analysis model. It can be very, very slow, very cumbersome. It ticks over. Like in the past, Fenestra Pro used to have to rely on the Revit API for every event or every function that we carried out in Fenestra Pro, which tied up Revit. I heard Dave say Revit is single threaded, and that's absolutely right. Revit can do one thing at a time effectively, right? So if it's tied up doing energy analysis, it means it's not going to be able to do anything else. And if that energy analysis is taking ages, like 15 minutes, 20 minutes or longer, as we've seen in really big buildings, that can be just time that someone is sitting on their hands effectively, And then the last big problem that we, understood or faced was the model view, right? It's the Revit environment, the Revit interface is brilliant for lots and lots of different things, but because of some of those challenges or issues or warnings within the energy analysis model, It wasn't intuitive to the user where they were occurring, why they were occurring. And then in FenestraPro, we couldn't display our results on the model very easily. You know, we couldn't select spaces or surfaces very intuitively. So with version 7, we've done, you know, we've tried to solve some of those problems. We've leveraged the API to extract the energy model data and display it in our own viewer, as Dave mentioned, and you can see on the screen. I'm going to show you now. I'm going to jump in. And all of those functions that FenestraPro has always done, driving the geometry of your window openings, setting the specification of your glazing, looking at shading voices and applying them to your model, etc. All of those things can still be done, but they happen in our own viewer, in our own environment. They happen very nimbly, very dynamically. We can see the results extremely quickly. And then when we're happy with them, we can apply them back to the model, right? So like Dave said, we still have that two-way conversation with the Revit model. We're reading from it, but we're also writing back to it. And that value as part of the workflow is still there, but we're doing it in a much quicker manner. You know, and as developers, as Autodesk industry partners, we have a much improved display and visibility over that model. I'm going to just show you what I'm talking about, right? Lots of people will recognize and know this building. It's just this kind of Autodesk sample building. It's not the worst model by any means, but like, you know, I mentioned that we'll look at one simple problem, right? There's lots of curtain wall, there's lots of glazing to this building. If I just take one particular panel, one glazed panel to this building and look at some of the properties, I can see that there is a family there. And I look at some of the type properties. There's actually no properties to that glazing, right? It's glass, and you know, the designers clearly decided that that's a window and that's an opening, and the, you know, the visibility settings says as such, but there's no visual light transmittance. So therefore we're not going to understand daylighting. There's no thermal resistance. So therefore we're not going to understand heat loss, and there's no solar heat gain coefficient. So therefore we're not going to understand heat gains, right? So that's what I mean in terms of some of these problems that occurred, you know, in the Revit energy analysis model. So users would effectively come along looking to understand the daylighting in these office spaces or the thermal performance of my envelope, and they'll open FenestraPro, and no values will, you know, they used to see no values because their glazing had no properties, and they get frustrated, or they didn't understand why, and you know, they'd kind of move on and go, look, I don't have time for this, and I'm on a deadline or whatever, you know. So we've adopted a new workflow. One of the first things about FenestraPro7 you'll see is we've created our new ribbon, and we've, you know, broken the pieces of FenestraPro into components, with more components to come, and I'll speak about that very briefly towards the end. But effectively, this is a detailed model, right? It's not in the conceptual massing environment. We're going to open FenestraPro. From there, we can start playing with some energy model settings. Like we can start looking at the perimeter zone. We can start looking at the analysis mode. Lots of different things that we can do, you know, through the energy settings that we can just drive directly from FenestraPro. But what I want to talk about is effectively identifying these issues, or let's just even say this issue, this glass issue. There's no properties to this glazing. So the first thing that's going to happen is FenestraPro is going to extract that energy model data. Right, so it just takes like, you know, 30 seconds, maybe 60 seconds to pull that out. It's creating the energy analysis model, and it's going to recreate it in FenestraPro's viewer. And because of that, we can start showing some problems, or representing some issues and representing the model. So pretty quick, right? Like, you know, using the Revit API in the past, we'll have found that this could have taken 5 minutes to do. You know, this is pretty quick, right? So immediately we're into this, you know, call it an on-ramp, call it a wizard. You know, we're continually updating this, but I can see the representation of my model here, and I can, you know, play around with it in lots of different kind of model settings, etc. But down the side, I can see the FenestraPro functionality, right? So I can see my setup, which I'm in at the moment, my design, which I will move on to next, and then my outputs being that kind of tangible objective of what I'm doing. I want to see data and I want to see reports. The first thing I see is there's lots of warnings here, right? So there's glass, first of all, without analytical properties, which I know about, right? Because I just told you, right? But I may not have known that until now. And then lots of different warnings remain. And here's some of those warnings. I've no analytical properties to my glass. There it is. And that's what I was talking about. I just picked one of those, didn't I? And there's that curtain wall. There's no analytical properties for that glass. Therefore, I won't see daylighting. I won't see heat gains. Also, there's no thermal property for the walls. Probably all the external walls in this building. There's no thermal properties. There's no U value set, so I won't understand any of those things. Likewise with floors, roofs, etc. And then also there might be other issues that arise that will be like located here, and I can mouse over and see them. But I don't want to just see them, I want to fix them. Okay, so the big problem for us was the glass. And we've dealt with it by doing it extremely quickly, right? So I can assign my glass. I open a quick fix, which is going to show me here's the types, here's the family types of glazing that are in your model. They're called glazed F-Pro, blah, 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 but there's no properties to them. I can fix them, you know, one by one, or I could fix all of them together, and it just applies a default property to them, right? So it's done. Like that's it. That's all it takes is just like click a fix button, and it applies a U value, it applies a solar heat gain coefficient, and it applies a visual light transmittance. Pretty baseline stuff, right? Like it's not triple glazed argon filled U values. It's just going to be quite a, you know, standard double glazed unit and the associated factors, you know, values that will come from that. So immediately a load of warnings just get eliminated. The next thing is I can start looking or checking or validating some of my model, some of the aspects. My viewer's gone crazy here. Some of the aspects of my viewer. So I can look at those analytical surfaces. Really importantly, I can look at the spaces, which me personally, I find this more useful, right? So I can see all of the analytical, you know, rooms and spaces within this model. And when they're not there, you see this kind of ghostly outline. So I can see there's 3 stories of spaces there. So I know that looks pretty good. I can look at the external walls and the envelope of that building. Likewise, the internal walls to, you know, make sure that the categorization of all those walls are correct. Roofs, floors, room boundaries, etc. So it's just let's call it a sanity check. It's a visual check as I run through it, and, you know, even checking levels and stuff like that. And like I said, this is not a bad model, and I purposely did that because I just wanted to show you one sort of small thing, being the glazing. You know, but like very often we can do these kind of automatic testings as well, which if there is really bad stuff, very often you can fix it automatically. It will fix the room bounding aspects. It will sometimes, depending on the model, fix external versus interior functions. You know, you're not going to be able to fix overlapping walls or roof, floors, etc. But again, it will highlight them for you. You will know where they are, and you can select it in the Revit model. So we can continue that now. Remember the walls, we had no U value. Okay, we fixed our glazing, but remember we had no U value to our walls or roofs or whatever. Well, how do we deal with that? Well, because we have a location in Revit, we can say, well, my building is based in Boston, Massachusetts, or Charlotte, North Carolina, or London, UK, or wherever that might be. Fenestra Pro will identify the codes in that particular territory as best as we can, whether it's the adopted code or a couple of codes that had been, you know, outdated recently. So say, for example, in Boston, Massachusetts has adopted this ICC 2015, for example, but it also has energy conservation code XYZ or whatever. These will come up, okay? And I can select whichever one I want to apply. I can also create a code, and that will open a link to our browser. That doesn't look good. Oh no, there we go. So I'm logged in. I'm logged in already. I can create my own code, and I can call it size code and share it with my firm, or share it with, you know, additional users or whatever, or find a code that I've created on a different project, etc., etc. And I can import that. I'm not going to do that. I'm going to just choose this ICC 2015. I'll select that. I'll continue the setup. And remember the walls and the roofs that had no glazing? Well, I can apply the standard U value that's been assigned by that code to my glazing, or to, not my glazing, to my walls and to my floors and to my roofs. So again, baseline stuff, but we think it's going to comply, you know, and that is starting to give me an understanding of, you know, how my building is performing. That you're not locked in on that. That's just your baseline. That's your starting point, and that gives you a place to jump off with Fenestra Pro. Then we're going to calculate solar loads. We're going to calculate shading. I'm hoping this doesn't take too long. You know, it seems to be rapid enough. And when we're good, it opens it up in the Fenestra Pro design tab, and I can do all of those things that Dave walked through. I can apply glazing. I can apply a specific, you know, glazing geometry. I can spec my glass, you know, from our product database. I can apply some shading and understand that shading, and then crucially, I can start creating reports. You know, I can start you know, slicing and dicing, and I'd want to report just on the window to wall ratio and the shading to all those different facades, or I want, you know, a schedule of all the glazing in that building and what the material or what the specification is and what the properties are. So loads of different ways that I can create reports and play around with that data. It's taken a little bit longer than I thought, and I have probably taken more time than I thought doing this little workflow. So I might let's see how this goes for another minute. I might just kick back to Revit and talk. No, I might kick back to PowerPoint. I mean, no, let's leave it. Let it go. And, you know,
there is a question there, Simon, on do linked models influence the Fenestra Pro model?
Yeah, totally. So linked models, another, you know, question that came up in the past with a number of firms, and you know, we support them very effectively now. The thing with linked models is obviously if your model's linked in, it's Fenestra Pro is going to read it. Like as long as the information, or as long as it's room bounding, Fenestra Pro is going, and the energy analytical model is going to read it, but we don't have the ability to write back to a linked model. We can write back to that kind of, you know, the model, the central model, but not the linked model itself, right? So, so if you are linking in your envelope, you're going to be able to analyze it, but you're not going to be able to impose change. I hope that makes sense. So yeah, like, you know, as Dave walked through this kind of quickly earlier, but like we can, you know, select different facades and, you know, different surfaces and see the glazing, see the heat gains in those surfaces, you know, one by one or cumulatively or whatever. We can certainly look at heat gains as an average or as peaks. We can dig into it and look across the year. What does that look like? You know, lots and lots of ways we can manipulate and start playing around with that data. Not just looking at surfaces, though, we can also look at the spaces, right? So I mentioned this is like, you know, a favorite of mine, and, you know, oh, sorry, my mouse is a bit dodgy. You know, I like this view and I like being able to understand the spaces. So if we start choosing offices, you know, within this space or perimeter zones or whatever, you know, we're getting accumulative values, right? So say you might have a space on the corner that has glazing to the south, but also glazing to the east, right? So certainly we shouldn't be just looking at the south facing values in, you know, in isolation. We need to be looking at it accumulatively, and what does that look like across the pattern of a day or a year or whatever that might look like. So it's a really intuitive way of starting to look at it, and then obviously you could dig into those spaces, see the analytical surfaces that are included, and from there even see like what are the architectural elements to those you know, to those surfaces and what openings are in it. And, you know, there's a level of detail and granularity that if you are so inclined, you can really dig into quite effectively. You can add windows, add curtain walls, add shading, start playing around with our quite extensive glazing database, and, you know, applying product manufacturers details, Guardian Glass, Vitro, I believe some Viricon in there, etc. And then, as I said, creating reports, right? So exporting all of that information to your reporting platform and being able to dig in, right? So this is all of the info from that I just generated immediately from this model, just very quickly. All of the climatic information, all of the different orientations, all the geometric info, glass to wall ratios, areas per surface, areas per facade, etc., like massive amounts of information. And then getting into the properties and the materials. There's a lot there, as you can imagine. And like, I don't know about you, but I'm not going to read all that, but I certainly might create my own report. So I can create a new report that might be, areas based, that rather than surfaces, I want to look at orientations, and I look at the area of glazing, but I also want to see, I don't know, solar heat gains or solar loads across those, oops, I didn't turn it on, across those different orientations, and I can start applying, whatever I want to do. I save that, I can export it, I can share it, all of that kind of information. I am probably going on a little bit long, so I wanted to kind of jump back into, how do I do this, into my PowerPoint. A lot of this is actually just repeating what I kind of went through, this model checking aspect, advising on model issues and warnings, assigning different properties to particularly glazing, because that's the thing that FenestraPro really hangs its hat on. We want to be able to drive the glazing. Dave kind of touched on earlier, the glazing has enormous impacts on the energy performance and the emissions of your building. We can visualize them, review them, and crucially fix them in a really kind of streamlined, quick being the operative word here, manner. But also localization, like we can suggest and apply regulations and codes based on the location of your site and your model, and start applying just baseline codes for U values for walls or roofs or whatever that might be, and then you start having an understanding, am I compliant or not? Like if I've got 80% glazing at a certain U value and I've got 20% wall at a different U value, does the overall thermal performance of that envelope still comply? I can see that in FenestraPro like extremely quickly. And then navigation selection is just really, really intuitive in FenestraPro in 7 in our new viewer. It's a lot quicker, it's a lot better visually, and it's a lot more nimble. And I think that's probably one of our greatest, strengths at this stage. Probably just to finish up, I can talk about this real quick, is this kind of integration with Insight. FenestraPro works very well with Insight, in terms of Insight is obviously much more broader whole building energy analysis. It looks at systems, it looks at the entire building, but it doesn't have the level of granularity around the facade as FenestraPro does, right? So we can't, in Insight, we can't apply different glazing to different facades or different surfaces. We've got to make quite broad stroke decisions. However, FenestraPro does that in a huge level of granularity. The second big difference is Insight is not tied to, not inside Revit, right? It pulls the energy analytical information as FenestraPro does, but it's outside, it's on its own separate platform. FenestraPro, as you probably have guessed, is very integrated inside Revit. So working on loads of really great stuff with the Autodesk team and integrating, between FenestraPro and Insight and next gen Insight and systems analysis and all of that kind of stuff is on our kind of dev roadmap at the moment. Just 2 minutes just to talk about stuff that's coming up and stuff that we are working on. And Dave kind of talked about it, like in FenestraPro, we're very performance led. We look at those, as he put it, the metrics that matter, right? Heat gains, daylighting, thermal performance or heat loss. But I think increasingly, or, maybe that ship has sailed, maybe this is it now, is like carbon, right? So operational carbon and really importantly, embodied carbon. And that's something that we're working on quite heavily in FenestraPro as well. And specifically in our world, how does your facade or your envelope impact carbon emissions, both operational emissions and embodied carbon emissions? So just to kind of give you a flavor of where we are going with this, we're starting to leverage the systems analysis piece, which uses Energy Plus in Revit, to start generating energy use, and like, what is your envelope really impacting, and what is different types of glazing impacting, what's different window to wall ratios impacting. So using Energy Plus, we can start extracting that operational energy use, and what is influenced by the facade. But likewise, operational energy is not the only show in town, and increasingly over the past few years, embodied carbon has become more and more prevalent and more important, especially as we move towards like net zero buildings, or very low energy buildings. So what we're looking at doing is a couple of things. Again, Autodesk are doing really great stuff with Next Gen Insight, and their Carbon Insights tool they have on a tech preview at the moment. What we would like to do in Fenestra Pro is, again, like, rather than looking at the embodied carbon of the entire building, which is what the Autodesk are doing, we want to look at the embodied carbon of the facade, or the envelope, or the glazing, or that level of granularity, right? So we have those two things now. We have operational energy, which we can, convert to operational carbon, and we have embodied carbon. Sorry, this isn't animated, but like, let me point. We have operational energy for the entire building, or operational carbon. We can certainly identify what's influenced by the facade. We have embodied carbon for the entire building, and we can identify what the embodied carbon that's influenced or within the facade is. And that data alone gives huge sort of influence into your design decisions. When you lay them on top of each other, and you go, well, my operational carbon influenced by the facade over, say, 20 years or 25 years looks like this, and the embodied carbon of that facade looks like this. It just gives huge granularity into that kind of those envelope or shell decisions that you can make at design stage. And as we said, the envelope impacts more than half of the energy use of your building, and here's how we're looking to address that. So we have FenestraPro7 on free trial there at the moment. I think there's a QR code there which you can scan with your phone if you want to real quick, or take a screenshot, or I don't know how you do that, but certainly you can go to fenestrapro.com/free-trial, or just go to fenestrapro.com. You'll find it pretty easily. We'd love to hear from you. We're happy to support a free trial, happy to kind of engage and dig in a little bit more with people as required. Dave, I don't know, you were keeping an eye on the chat there. Is there any further questions?
Yeah, there's one other question in there. Do manufacturers provide the information about each material directly to the model, or have I got to enter the information? So let me briefly explain. As we've demonstrated there on a couple of times, we have a database of different glass types from different manufacturers, predominantly from Guardian and Vitro. Guardian very much, different regions globally, and Vitro very much in the US. and so they provide us with a database. So that database is embedded within the software. So as you saw when you scroll through and you refined your search based on the component, or based on the properties of the glass itself, or you could say based on the requirements for your, I suppose, performance on the building, you can refine and select from that list and link back to the manufacturer's information. So that's our kind of standard list of standard database, and that's used early in the process and into that kind of detailed design stage. But they're all made up of, those glass makeups are all 6-12-6. In other words, 6 mil inner leaf, 12 mil cavity with a 6 mil outer leaf, or a 16 mil cavity, as is the case in Europe. When you're going to that later stage and you're refining your specification, typically you're going to require variation in thickness depending on the size of the glazed unit, first of all. Second of all, you might be looking at safety control glazing, such as a double laminate on your extern, or heat soaked and toughened unit. So a couple of things that can happen. You can log on to Vitro's Construct IGU or Guardian Glass's performance calculator and create your own bespoke glazing makeup to meet the performance criteria that you've set out in the first instance. And then you can import that back into Fenestra Pro in a very simple way. Or you can have somebody from the manufacturer share that glass makeup with you. So again, they have the expertise in creating these bespoke makeups that they can share with you, and you'll receive an email to say Vitro have shared this particular unit with you, and when you open up Revit, it'll be there in your bespoke list. So a couple of different ways of taking the manufacturer's information and bringing that in. I would also point out as well, we did talk about some manufacturer's information there, but also in our database, we have generic glass types, and that fits the bill for, let's say, government contracts where you can't name a manufacturer and you just want to use a generic piece of glass with specific or particular glazing properties available. So that's the, hopefully that answers your question. I don't see any more questions, but now is a good time to ask if you're, I know we are top of the hour, so we're probably about to finish up. I hope it was a useful presentation. Thanks, Simon, for your piece. Any other questions? I'll take that as a no. And on the basis that
nope,
they're
not from what I can see.
great, Meg, thanks. So look, on the basis that we, oh, hang on one sec. Thanks both for the presentation. No, our pleasure. Hopefully you took something away and can see the benefits in terms of how you can optimize the design of your facade based on what we're doing. Justin, thanks for your comments there. We'll catch up soon, actually. Good to see you on the call. And look, thanks for your time, everybody. And we look forward to hearing from you soon. One of the guys, either Meg or probably Jay, will reach out and see if you require any further information. But if you do require any further information, my email address and Simon's email address is on the screen there. Feel free to take a screen grab and reach out to us yourselves. Thanks for your time, and I'll leave it at that. Take care.